Hello, am I audible to all? Hello, Sahil. Am I audible?
Yes, Rupam, you are audible.
Yeah. So, good evening. My name is Rupam Mankar. I am the co-founder and chief operating officer here at CodeClause. Welcome to this webinar on data science from CodeClause. Today, we have an amazing speaker with us, Mr. Sahil Ratnaparkhi. He is data science enthusiastic and has hands-on experience on data science as well as data analytics and machine learning. We at CodeClause are delighted to have Sahil Ratnaparkhi with us today as webinar's guest speaker. So, the warm welcome to all. Please keep practicing and we will provide certificate after the successful completion of this webinar. Over to you, Sahil.
Thank you so much, Rupam. Good evening, everyone. My name is Sahil Ratnaparkhi, and I am with Team CodeClause. So let us begin today's session. Is the screen visible?
Yes, it's visible, Sahil.
Okay, thank you, Rupam. So good evening, guys. Today we are going to learn about linear regression, and I think it is a very interesting topic, and you guys will love it. So today's agenda
Every,
is
uh, sorry for the interruption, Sahil. Everyone, please put we are in webinar in the chat so that we will get the confirmation about that.
So today we will learn about linear regression. So first we will understand what linear regression is, what is the concept. Then we will do some data visualization on the data set. Then we will learn about correlation, and then we will have some hands-on on linear regression. So what is actually linear regression? So linear regression is a form of predictive modeling technique which investigates the relationship between dependent and independent variable. So in short, suppose you have two variables like age and salary. So consider age independent variable and salary a dependent variable. So how will the salary change according to the age? So let's say that a person with age 40 has more salary than a person with age 25, considering that they are in the same company. Given that their experience is different, as the person with the greater age has more experience. So linear regression actually what it does is that it finds a straight line that best fits the given data points. So you are given some data points. So it finds a straight line that is closest to all the data points, and it is also known as the best fit line. So linear regression is actually given with a formula. The formula is y is equal to mx plus c, where y is your dependent variable, say the salary, x is your independent variable, age. M is the slope. So what is slope? Slope is actually slope actually tells us that with each increment or decrement in the independent variable means the x, how much the dependent variable changes. So that is our slope, and C is the intercept. Intercept basically means that at which point on the y-axis your regression line intersects the y-axis. So this is our linear regression is defined by this equation y is equal to mx plus c. So what let's see what are the major uses of linear regression. So the major uses of linear regression are it can determine the strength of the predictor. So what this basically means is that suppose you are given two variables. Let's say you are working in an IT company, and the two variables are your salary and your height. No, the two variables are experience, salary, and based experienced and height. And based on experience and height, you have to predict the salary. So what linear regression does is that it predicts that which variable has more strength as a predictor. Like your height has to do nothing with your salary. Means your height can be anything. It does not depend and it does not change with salary. But your experience changes your salary. Means like if you have more experience, you will have more salary. So linear regression helps in that. The second is uh, forecasting the effect. So forecasting the effect means how much the dependent variable changes with the change in one or more variables, one or more independent variables. In this, uh, you can ask question like how much additional sale income will I get on each 10,000 rupees spent on marketing? Means if you change the x, how much will the y change? And the third major use is trend forecasting. So what trend forecasting is does is that it predicts the trend. Like for example, you can ask what will be the price of this stock in the next 6 months. It can answer such questions. So linear regression is a pretty useful algorithm, and it is like the base of machine learning. Yeah. So let's see in short what you have learned until now. So what linear regression does is in linear regression, the data is modeled using a single straight line. So it uses a single straight line to model the data. Means you will get only a single line, and the single line will predict the data. And the second thing is it predicts the output in single variable. So the output you will get will be a single variable like salary or maybe the price of a stock. Like this, you will get the output of a single variable. So this was all about linear regression. I guess if you have any doubt, you can ask now. Feel free to type it in Q&A session. Okay, so I think no doubts here. So let's move on to the implementation part. So for implementation, at first we will need to import some libraries like pandas and numpy. So what numpy does is that numpy is a Python library. It is used for working with arrays. And pandas is a powerful library which is used to manipulate the data frame. Is the screen visible to you all guys? Please reply in the chat box. Okay, okay. Okay, so let's move on. So matplotlib is a data visualization library. It is used for plotting the data and create interactive visualizations in Python. So Seaborn is another data visualization library which is built on matplotlib, and it gives us enhanced tools for visualizations. Okay, so now let's import the dataset. The dataset link is provided in the chat box, so please use that link and download the dataset so that you can also work on the dataset with me. So our dataset is in .csv form. Is the screen visible to you guys, or is it like freezed? Okay, it is not frozen, right? Okay, thank you, thank you. Okay, so our dataset is in CSV format. So we will use the read CSV function from the pandas library, which we imported as PD. So let's import our data set. So let's check out how our data set look like. So df.head, what it basically does is it shows us the top 5 records from the data set. If you want to see like some 10 or 20 records, you can specify the number of records you want to see, and you can run this cell by using shift and enter. You can run the cell using shift and enter. So it is a shortcut for running a cell. So now if you want to see the bottom records, like bottom 5 records, you can use df.tail. Df is our data frame, and tail is the function. So using this, we can see the bottom 5 records, and in tail you can also specify the number of records you want to see, like any number of records, and it will show you that number of records from the bottom. By default, it shows 5 records. So next command is df.shape. So what df.shape does is that it gives us the number of rows and columns in the data set. So first, we are what we are doing is we are exploring our data set, and we are basically checking what data is contained in our data set, and how it is distributed. Okay, so df.size is also a command which gives us the total number of cells, which is 50 into 5. So to see how many cells are there, you can use this command. So our next command is df.info. So what df.info does is that it gives the number of total columns, and it gives basically the null count and the data type. So let's see, the R&D spend column is of float data type, which is basically numerical. Administration is also a float, which is also numerical. Marketing spend is float. State state is object, which means it's string, and it has categories. And profit is also float. So we will further explore this data set. Let's see. So df.describe gives us the total count, mean, standard deviation, minimum, maximum, the 50%, 25%, and 75% of all the columns, of all the numerical columns only, which means that it will not give data on the object data type, that is the state column. So it shows the middle value, the 75%, 25%, the standard deviation, minimum value, and maximum value of each column. So let's see. Let's explore this state object. What is the state? So so using this, we can access the state column of the df data frame, and it shows that what is actually there in only state column. So as you can see, there are city names like New York, California, Florida, New York, Florida, California, Florida, New York. So it consists of these names. So let's see how many column, how many rows of each are there. Okay, so using value counts, you can get the key and values. Means the key is the city name and the total count of each city name in the dataset. So there are 17 New York entries, 17 California entries, and 16 Florida entries in the dataset. So let us check for null values because we often get to see null values in the dataset. So using is null function, we can see whether there are any null values or not. So false means there is no null value, and true means there is a null value. So if we have to sum it, we can use dot sum, which gives the total count of each column. So in each column, how many null values are there? So as you can see that R&D spend has zero null values. Administration also has zero null values. Marketing, state and profit also has no null values. So let's see. Suppose you want to sort and see that this dataset is about startups. As we can see that startup, that how much a startups spend on their R&D, uh, what is the marketing spend, and what is their profit. So suppose you want to check that which companies spend maximum on R&D, so you can check that too. Okay, guys, please wait for 2 minutes. We will continue in 2 minutes. Okay, guys, let's continue. If you feel that the screen is lagging or my voice is lagging, feel free to comment. Okay, so let's continue. So say suppose you want to see that which country, which which startups spend most in their R&D, that is research and development, you can use that. You can do that by using the sort values function. We will just do that df dot sort values, and in that we will pass the parameter by, and here goes the name of the column. So the name of the column is R&D spend, and dot head gives the top 5 startups. So as you can see that okay, it is actually with it is by default sorted with in ascending order. So to see that the most spend in RD, we have to sort it in descending order. So we can use the parameter ascending. Ascending equals to false. Yes. So by default the ascending is true. So we need to make it false so that we can check that which startup spend most on the R&D and how much it is. So as you can see, this is the most startup spends on R&D. The same can be done for marketing spend. So let's do the same for marketing spend. Just instead of this, we have to write the marketing spend. Yes. So as you can see that this is the most the company can spend on marketing. And if the next question you can ask is how much is the maximum profit? So for that you can use the same command, and just instead of marketing spend, change the column name to profit. Yes. So this is the maximum companies earned profit. So this is how you can sort and see. If you remove the dot head, you can basically get the whole data set in descending order. But if you want selective columns, you can keep the head, and the tail command, the tail function also applies here. So you can use that too. So now let's do some data visualization. So in data visualization, we will see the data in a graphical format, means in the format of graphs, which will help us better understand the data. So this is our whole data set, and this is a bar plot of the whole data set. So as you can see, the amount of data is large, so we cannot see the exact numbers. So we will just reduce it. So let's say the top 10 companies, or maybe top 5 companies. Yes, so this is the data set of top 5 companies graphically. We can increase the value to 10 to see some kind of trend in the data set. Yes, so from the graph you can see that as the marketing spend increases, the profit also increases in most of the cases. So this might be a trend. So let's dig deeper into the data set. And now, so in this uh, plt.figure, actually we use this to set the figure size, that is the size of this chart, and SNS, that is the C1 library, allows us to plot it using the bar plot. So in bar plot, we pass two parameters. First is the X value, that is the marketing spend, and this is actually the using this we have taken the top 10 columns, only the first 10 columns, and the second is the Y value, that is the profit. Now let's use the scatter plot to find new trends. So this is scatter plot, and as you can see, uh, there is some trend. We might say that yes, there is a rise in profit with marketing. Means as the companies market themselves more, they earn more profit. So let's do the same with other columns, with administration and R&D spend. So in administration, we can say that there is no trend. Means increasing the value of administration does not exactly increase our profit. As you can see, the scatter plot is scattered all over. So we can confidently say that there is no trend. Administration plays very little to no role in increasing the profit. Now we will do the same using the R&D spend. So yes, here we can clearly see that as the research and development spending increases, means as the startups spend more on research and development, their profit significantly rises with the money they have spent. So here we can see a clear trend with the R&D spend. So is there any doubt till here? Okay, those who are performing this with me, please note down the code. Any doubts? Feel free to ask. Okay, if there are no doubts, uh, can we move on? Okay, thank you, Mahesh. So let's move ahead. So as we can see, there is a one feature that is basically an object, and we cannot give the machine the input of a object which is not a number. So machine does not accept something that is not a number. So for that we have to convert this into number. So this we can do using this technique we means which we are using is called one hot encoding. In this we will convert the state variable uh, into a number. So what we will do is, uh, let's see. So in state we have like three city names: New York, California, and Florida. So we will assign code to each city. Say for example, 0 for New York, 1 for California, and 2 for Florida. Or we can another approach is that we can make uh, three new columns which will have say for one column will have 1 for New York and 0 for the rest. Another column will have 1 for California and 0 for the rest, and the third column will have 1 for Florida and 0 for the rest. So in this way we can convert this into a numerical form and we can give it to our model. So let's try that. So we will create a new data frame dummy. So using this, we have created the three different columns. So let me show you. Yes. So I hope you can see this. Yes. So this first column is California, which gives one only if the state present is California. The second column is state Florida, which gives one if only the state is Florida. And the second and the third one is for the New York. So the first state was New York. So here it is 0, 0, and for state New York it is 1. The second was California. So the state California column contains 1 and the rest contains 0. And the same goes for Florida. So in this way we can convert the objects into numbers in numerical form so that we can feed it into the machine learning model. Now let's make the changes. Yes, so on dummy df, we will work on dummy df from here on. So what I did is I did the same procedure as I did with the dummy, and this parameter is drop first. What it actually does is it drops the California column, so we will have less data to process. So if both are 0, we can say that the city was California. If the state Florida and state New York both are 0, we can assume that the state was California. I hope I'm clear. Any doubts? Uh, yes, you can ask, but after the means after finishing this session, we will have a Q&A. You can ask questions about internship projects there. So any doubts still here? Okay, so let's move forward. So now we will start our simple linear regression. So simple linear regression, we have a dependent and an independent variable. So let's take the dependent variable first. Let's take the independent variable first. Let's name it x independent. At is it will be on the x axis and it is an independent variable. So as we need only one independent variable, we can drop other variables. So let's drop other variables. So dummy df dot columns, that is data frame dot columns, gives you the list of the columns that are present in your data set. So we will take R and D for this and we will drop the rest. So let's do this. So what we did is we used the drop function and passed a list of the column names, that is an array of column names, and that we want to drop. And what this axis one does is it tells the machine to drop the columns. Axis 1 means column, and axis, if we set axis to 0, it will mean rows. So let's take another variable. So in y variable, we want the dependent variable, the variable which we want to predict. So we want to predict the profit given the R&D spent. So we have taken R&D spent here and dropped the rest of the columns, and here we have taken only the profit. So now let's import some more libraries. So for this we have to split the data using the train test split. What it basically does is that it splits the data uh, like in 80-20 or 70-30 ratio. That is the 70 is for training and the 30% is for testing. So let's import. Yes, so we have imported this, and we will also need one more library uh, for our linear regression model. So let's import that too. Yes, so we have imported both. One is for splitting the data set and one which contains our linear regression model. So let's move further. So we will split the data set into training and testing, and so let's do this. So we are using train test split. So in this we have to pass the independent and dependent variable. And the third parameter will be test size. It will basically allow us to tell the model that in how much ratio we want the test and train size. So let us do 80-20. So we will give 0.20%. Yes, and we can also add one more parameter, that is the random state. So what this random state does is that it ensures that every time we split the data set, it will give us the exact number of splits. I hope you are following me. So now let's build our model. So we will use the training set to fit the model, which means that we will train the model using the training set. Yes, so we have fitted it with X train and Y train. So let's predict the values. So for that we have the predict function. In this we will pass the test the independent value for the test set. Yes, so it has done. So let's check what are our models. For that, first let's build a new data frame. Let's say dt. So what we will do is that we will store our predicted value and original value in this data frame so that we can use it according to our convenience. So let's name this. So we have taken the first column and we will store the y test values in there. So in pred column, we will store the predictions that we made. So we have added three columns, that is y test, which will store the testing values, which are the values for the test set, and the predicted values in pred, and the R&D. R&D in R&D we stored the uh, values of R&D column, and using this iloc, what I did is that from the test x test I took the first column and inserted it in R&D. So let's see how much our prediction was right. So we can visualize it using the scatter plot. So I have plotted the original data, that is the data from the data set, on a scatter plot, and the predicted values will be plotted using a line graph. It will be shown in a straight line. So let's add the labels. So I hope you can see this. So this is how our graph looks like. So these dots are the actual value, and the line is our predicted values. So by this we can see that we have our model works actually pretty good, and it makes near accurate predictions. Not, it will never make I guess accurate predictions, but it will come close. So see uh, let's see it in numerical form, means how much accurate our model actually is. So for that we can use first we need to import a library for that. So this is the mean absolute error. So we will use this to quantify, means to see how much accurate our model is. So let's see. Yes, so this is the our score. So let us make it better. Yes, so 94 and 96. 94 is our training score, and 96 is our testing score. So from this score we can say that our model was pretty accurate. So we have one more parameter to see. So this is our mean absolute error. So what this basically does is, in the back it calculates the difference between the actual point and the predicted point, and it does this for every data point. It calculates its mean and returns its absolute value, that is the positive value. So this is our mean absolute error. So we should focus on reducing this error as much as possible. So for this, I think it's a pretty good score for this data set and for linear regression. So this is our linear regression. I hope you understood until now. If you have any doubts, feel free to ask in the chat. Okay, so Vittal, good question. What is SNS? So let's see. So SNS is a data visualization library. Basically, Seaborn is a data visualization library which we have imported as SNS. So every time we would not need to type Seaborn. Instead, we can use short form SNS. And SNS is not the it's not compulsory that you should use SNS. We can use any characters. But in the industry, normally SNS is used. So we can use SNS. I hope you understood. Just an abbreviation. Yes, yes, Aryan. Ayan. Ayan. Okay, any more questions? Please feel free to ask if you have any questions about this, about the data visualization. Okay, thank you, Vittal. Any question about the code or data visualization, please ask. How to know which graph to make? Okay, good question, Ayan. Actually, at first we start by plotting the standard graphs like bar plot, scatter plot, and histogram is the most popular among them. So, we start by that, but as you practice more in this field, you will see that you will actually get the feeling of which graph you should use. It basically depends on the data. So histogram is almost every time histogram is used, bar plot is used, scatter plot is used. But as you practice more, you may find it necessary to use additional graphs like box plot or pie chart, depending on the data set. So if you practice more, you will get the feeling which graph is best suited to use. But at first, you can start by using all the graphs that you know. You will get the feel of the data set. How is your data set? How is it distributed? And as you go further down the road, you will learn about which graph best suits depending on the data set. It was a good question, Ayan. Thank you. I hope you understood. Okay, thank you. Thank you, Ayan. Any more questions? What is specific value of does this visualization bring? So, do you mean to ask that what is the use of visualization? Am I right, Shruti? Okay, yes. So, why do we usually visualize? So, there are two main reasons for visualization. The first reason is to understand the data more. You can see the trend. See, as in this shown in the bar graph, as the marketing spend is increasing, the profit is increasing, and it is more showing in this scatter plot. And so we can, based on this, we can means understand which model to use. And the second reason is while you are working as a data scientist, you have to means show your findings to your peers, maybe the stakeholders or a marketing team or your manager or some your boss. So they might not understand the numbers. Like if you show them that my model score is 94%, 96%, they will not understand it. So you have to show them visually, like you can say that suppose you have shown them, this graph. So you can say that look here, with the R&D, our profit is rising significantly. So our doing spending money of R&D was a good thing, and using this, so this is also a good example. Like spending on administration has nothing to do with profit. So you can tell the company that spending of administration is not worth because it does not increase our profit directly. So I hope you have got your answer. Please respond. Okay, thank you, Shruti. Any more questions? Okay, thank you, Ayan. No more questions. Okay, Kalpita, what is your question? Hello, Kalpita. If you have any question, please type it in the chat box. Any other models we can use instead of linear regression? Okay, good question. Okay, there are other models for this case, like for the 50 startups dataset. You can use multiple linear regression. What it basically does is it takes more than one independent variable. So like in this case we have taken with R&D, and using R&D we have predicted the profit. So in multiple linear regression we can use multiple such variables. So like you can use the marketing spend and R&D together. You can also add administration in that, and if you visualize that, you will get multiple such lines. Like in this case, you can get three lines each for different feature. So you can use multiple linear regression. There are other advanced models like XGBoost, but that is out of the scope for this session. So multiple linear regression is another good option. So you can try that. And I would like to say that while you are doing this, feel free to use Google, as it is a good resource. You can find anything, read the documentation. You will learn a lot from that. Any more questions? Okay, thank you, Kalpita. Okay, thank you, Mahesh. Give me a minute. Okay, no more questions. Okay, thank you. Okay, thank you everyone. I hope you found this session useful. Uh, you learned at least a little bit about linear regression, and I would like to say that linear regression is the most basic machine learning model, but it is also the most important machine learning model using which you can learn about after that you can learn about various models. So it is a good foundation to have. Uh, yes. So and I would at the end I would also like to say that CodeClause CodeClause is a place where internships are offered. It is a good place for freshers to start their internships and to start their careers. So please feel free to reach out to CodeClause team. Uh, what will you get? So you will get an offer letter, a certificate, a letter of recommendation, and swags, which includes t-shirts. So please feel free to reach out to CodeClause team and ask if you have any doubts. It's a good place where you can belong as a developer and start your career. And believe me, you will learn a lot from this. CodeClause has domains like web development, Android development, data science, artificial intelligence, Python development, Java development, graphic designer, and content writer. If everyone do golden task, will all students. Okay, so I hope you can see the screen. So this is what CodeClause has to offer for you, and CodeClause actually welcomes freshers because CodeClause is a startup. So feel free to reach out to the team, and or you can go to internship.codeclause.com/apply, or you can reach out to the team. Please check out our handles on LinkedIn, Instagram, and Twitter. In the chat box, the link to the LinkedIn post is posted, so you can refer there, or you can go to codeclause.com. and you can also check out the account on Instagram. I will put up in the link, put the link in the Q&A, so you can check. Please check out the handles, guys. They are providing a good opportunity for you to learn. You get to work on real projects, so you can add that on your resume, and you can also learn something new. They are working on some industry projects which will help you to learn about new skills and how actually work is done. In the chat box, the link for the YouTube channel for CodeClause is posted, so you can check out previous lectures that has happened on from the CodeClause. Okay, thank you guys, and I would also like to thank CodeClause for providing me with this opportunity, and thank you all who have attended the session. You will be provided with the certificate after this, and this session will be available on YouTube. So I would like to thank all of you and Team CodeClause. Thank you. Bye.
Yes, guys, thank you for joining. You can leave the webinar now. Thank you.